How'd the game go yesterday?
We lost.
I heard.
By how much?
That's why I heard I was your mouth.
Oh,
67.
actually, no. And that's why you won. Who do you play?
Yeah, that's pretty.
So big. Yeah.
Okay, here we go. Let's go ahead and do some problems, right? The equation and solve. We'll just call this number 1 for today. Okay, so they're going to have 18 is what percent of 76? So when they have something that says like write the appropriate equation, just like I said on the mid-chapter assessment, write a proportion, then solve. You'll need to have some sort of equation set up, not just an answer. You'll need to have that equation written, and then we go from there. So in this case, it says 18 is what percent, excuse me, of 76. So if I'm reading this, I'm going to read it as 18, and then what is in mathematics? Equals, okay. What, do we know what the what is? No, so we say maybe X, or you could put P for percent. P of, what's up in mathematics? Times. Now, I only write this, this is typically not the way we would write it, because we usually say P dot 76. No, what do we usually write this as? 76p, right? So we usually write it as 76p. If you wrote it like this, I definitely want to mark you wrong. It's great. There's your equation, and now we solve. How do you solve for p? Divide both sides by 76. So go ahead, divide both sides by 76, and let's see what we get out for p. Go ahead, do the work on there. If you like I said, you can use a calculator. We just don't have one on the test. So if you're like, all right, I'm going to pull out the calculator and solve, that's fine too. Long division is the route we would go. Okay, I'm getting out 0.236. Is that anybody else getting out that?
Yes.
And then carrying on. So in which case they don't, they will tell you round to the nearest hundredth, and then percent to the nearest whole percent. So in this case, they just want the nearest whole percent. So we have come up with so far 0.236, right? The thing about this is that have we found a percent? No, we just found a decimal. Now, how do we convert it to a...
Move the decimal place to...
Yeah, move the decimal place 2 times. So we just move it twice to turn it into a percent. And so you say, okay, the percent is 23.6, but they say round to the nearest percent and whole percent. So you would just say 24%. Okay. Again, longhand work on a test, that would be a reasonable question, right? We don't want you spending 20 minutes doing this part, but it shouldn't take you too long. It require a little bit of work there, but you could have one of those possible. All right, now what about this one? It says 10% of is 50. Okay? So 10% of what number is 50? So go ahead and write an equation of this and then solve. You can, again, check with your cheat mates. 10% of what number? Pro tip is usually before you get into solving, you'll get rid of the percent and turn it into a decimal before you solve. So that's usually what we do. Did you break your wrist?
No, I sprained my thumb.
All right, so let's go ahead. We can at least write the equation up here and then see what we did from there. So it says 10% of, so what is of in mathematics? Multiplication of what number? So if you don't know the number, assign it a variable. What variable do we want to assign it? N, X. Okay, so I would write 0.1. Where did I get the 0.1 from? I addressed this. 10%, right? Turn to decimal. Of is mathematics, and we say n, and then is 50, and then you can divide both sides by 0.1. Another thing you could recognize is that 0.1 is also the same thing as 1/10, right? And then you can just multiply both sides by 10, or you could have recognized up here, you can multiply by 10 and get rid of the decimal and it turns into 1n. So however you want to do it, we end up with 500 for that. All right, let's go to another one. This is find the percent change. Oops. Find the percent change. So we will have from well, we can do this one, it's fine. From 200 to 100. What is the percent change? Now, a lot of people could look at that and probably just do some mental math on that, and that's fine. Not opposed to that. So you're going from 200 to 100. What's the change? The percent change. Okay. So in this though, if there is a little equation for you, it's the percent change equation. We wrote it yesterday, and the percent change equation is you take your. You remember the equation? If you look back in the notes, what do you take? Okay. So the amount in change. So in this case, it went from 200 to 100, so we would go 200 minus 100 over the original, which was 200. And then why do we say times the 100 there? Where does that come from?
To make it a percent.
Yeah, that just turns into the percent. So, you know, over here, we didn't show multiplying it by 100 until the very end. We just changed it. So if you're like, hey, I'm not going to worry about that till the very end and then turn into a percent, that's fine as well. So you go 100 over 200 times the 100, and you could either, you know, you could cancel the zeros out like this. It's great. And then 2 goes into 150. Don't forget, this is turning into a percent. So when we do that, we need to make sure we say like 50%. Now, a lot of people could say, oh yeah, if I'm going from 200 to 100, that's 50% off, if you will, and that's fine. When the numbers become less mental math, this is the equation. Original minus the new, divided by the original, times 100 to give us the percent on that. All right, now let's go to find the new amount. Find the new amount. number 4. And if I have increase 90 by 250%. So I'm going to increase 90 by 250%. Yesterday I wrote on the board and we talked about it in terms of like discount. I don't know if you remember me talking about it in terms of discount, but I said, you know, if it's 35% off, I actually just multiply it not by 35% off and then subtract that, but I just multiply it by the 0.65 or 65%. This is the same thing except you have an increase 90 by 250%. So if you recall yesterday, if you're going to increase, okay, to increase the multiply, they called it the, I think, multiplication factor or something. Yeah, they call it the multiplication factor. The multiplication factor is you take your 100 plus your percent increase. So in this case, it would be 250, like that, and that's your multiplication factor. So you are going to actually multiply by, in this case, 350%. And the reason for that is that you are going to, the 100 represents you're keeping your original value, 100% of the original, plus you're adding on 250 more percent on that, okay? So what we would state is, if you wanted in the equation, you could write new n for like the new amount, whatever, is 350% times 90. Now again, we don't use percent. When we're doing our calculations, what do we use? 3.5, yeah, the decimal. So we're going to say the new amount is 3.5 times the 90, like that. So that's where. And again, why 350%? Because you keep 100% of your original value plus you add on 250 more percent. And so you go 90 times 3.5. What do we end up with 90 times 3.5? Anybody got that for us? Yeah, Zach? 315? Okay, so 315. I think I heard another 315. So, all right, well, let's go ahead and do, we just have, I think we'll do 3 more here. So we're going to write an equation and solve. Number 5 for us, okay, so a little bit of writing here. There we go. This is after 4 weeks of training, okay, at his job, Ryan will get a 7% increase in his hourly wage. Okay, that's pretty nice. 7% increase. Okay. If his increase amounts to 60 cents per hour, what was his original wage during training? Okay, so good work. I'm writing, you guys are writing, great job. Try not to do too many of these story problems at once. But so after 4 weeks of training at his job, Ryan will get a 7% increase in his hourly wage. If his increase amounts to 60 cents per hour, what was his original wage? Okay, try to set up an equation, chat with your cheat mate, and then we'll go over this together in just a minute. Now remember, you need an equation, and there might be, you could come up with a couple different routes possibly. So, you're not tied into one route, but you do need an equation, and then you need to solve it. Okay, so let's set up an equation. One way to do this is we know that his final amount, right, well, we don't know his final wage, but his original wage, but we know that his increase is, right, 0.6. So he's earning 0.6. What that means is that going back, we had a 7% increase, so 0.07, right, get rid of the percentage. 7% of his original wage, maybe we'll put W for wage. So 7% of the original equals a 60-cent increase. So that would be one equation you could set, 0.07 times W or a different variable. And then you could say, well, then if I'm solving for W, that will give me his wage. So we get 0.6 divided by 0.07. And anybody do that one for us? 0.6, what do we end up with? 0? 8.50? 8.57?
Yes.
$8.57 per hour. Okay. So that was his original, and then he got that 60-cent increase on that. So now he's up over the $9 mark. Good for Brian. Yeah, good for you, Brian. Okay, we got two more, and we're gonna have a nice chunk of time to work. Okay, we're gonna draw a little chart here. When we draw a chart or a table, complete a table. Remember, you don't have time to make this like super nice and so we're gonna do two problems off this table, and it's going to look like this. Okay, we have this, 4 sections in there, 1, 2, okay, and then we're gonna have this. So again, you can't make this perfect little table. You gotta just write the table and do it quickly. So the original amount is what's going to be in our first column. Then the change is in our second column. Then our percent change. Okay, again, you can shorthand that. Just write the percent symbol. And then new amount. New amount. Okay, so those are our 4 things given to us. As a brief side note, there is a symbol usually you use a lot in science and in math too, but that's a triangle. I understand that. Anybody know what symbol that is in science? Yeah.
Well, isn't that the amount of change, but it's delta?
The amount of change, yeah, delta. This is a Greek letter, delta. which means change in. So that's a good way to shorthand something if you're like, oh, percent delta means percent change in. Is there a company called Delta?
Yes.
Yeah, it's a airlines, and if you know what their symbol is, anybody know what their symbol is? It's a triangle. Yeah.
Whoa.
There you go. Crazy, huh? And so anyways, there you go. Now we're gonna do two problems, whatever this is, number 6 and 7. So this is number 6 and 7. So this horizontal will be one thing, the other horizontal will be another thing. And so let's look at this one. The information they give you is the original amount, whatever it is, this is number 6. The original amount is 590. Okay? The change, they're gonna tell you, subtract 40, so they tell you that. Then you have this unknown and you have this unknown. So these are the two blanks we need to fill in. One might get caught in the weeds of trying to do percents and dividing by 100 instead of percent changes and all this stuff. And then it gets confusing, which it can be confusing. Let us not get caught in the weeds for one of these two things. One of these two things is very basic math. Very basic arithmetic. Subtraction, yeah, good. You started with 590, you subtracted 40, what's your new amount? 550. Nice job. Yeah, it didn't have to do any difficult percent work. Now, to find a percent change, this we go back to, didn't we already do like a percent change right here? We did one right there, you bet. So how do you find percent change for this one? You take your, right, there's the top, amount of change. So what's the amount of change? 40 over your original. What's the original? 90. And then again, if it's a little confusing about the times 100, you're like too many numbers going in there, just hit pause and multiply the answer by 100 at the end. Okay, you could do that, it's fine. Yeah, Nico.
Could you divide 550 by 590? Because you're saying what percent of 550 is 590?
Well, if you went, that would be on the other part, how much is left. So yeah, if you go 40 divided by 550, okay, so we do that math, we can cancel out that 0 if we wanted to, and then multiply by 100. Go ahead and do that math. What do we end up with for that? And you'll probably round to the nearest tenth. Let's round it to the nearest tenth. I didn't state that. So let's go nearest tenth. Because otherwise you'll be calculating for a while. It's going to keep going and going and going. So we don't want to do that. So you go 4 divided by 59, and you end up with nearest tenth.
14.8.
I'm not liking 14.8.
Well, I wouldn't ask them to just round it up.
To the nearest tenth. Wow, okay, we're struggling here, guys. Here
I
we
want the
go.
100th and round it up.
So, 59, we go here, here, right? Here,
It's 1%.
here, and then here.
Um,
6 times 9, right, is 54, 35, so then we have 46. I feel good about that.
About 15 minutes.
Okay, and then a 0 is 0, 59 into 460, how many times? 7 maybe, and so 63, 35, 41, like that, and then we'd be left with 47. And then 0, and then 0. And then this is where you don't have to, we need to put one more number to check our rounding, right? So we know it's going to be either 7 or it's going to be 8. And it actually doesn't matter. Because either way, you're going to round which way? Up. So you could check though and say, okay, if I plug in, so we're going to say 7. So in this case, your answer is not 0.0677, because that's a decimal. How do I turn it into percent? Move it twice, so I have 6.77%, and then round to the nearest tenth. What's the tenth going to be? 6.8%. Again, that is a reasonable test question. Now, 30 of those, where you're doing longhand division, might get a little laborious and take too much time, right? So you're probably not going to have 30 of those, but you easily could have 1 or 2, no problem on that. So make sure you're savvy in your rounding and in your long division. Yeah.
I wrote 7% because I just rounded 6 over there. Would that be okay?
That's wrong. Rounded to the nearest tenth of a percent. Tenth includes a decimal. Now, if the answer was this, 6.98, let's say, and you're rounding to the nearest tenth, this would round the 9 into a 10, and therefore then it would just be 7.0%, or you could just write 7% if that was the case. Then it would round up. Okay? So make sure we know our rounding on that. Okay, the last one we're going to do here is if you have 70 is your original, unknown here, 22% change. Now, when they say 22% change, you need to know what?
Increase or decrease?
Absolutely. You need to go an increase or a decrease. So what they're going to say is this is a decrease. Okay? So now we have our percent change as a 22% decrease. So we'll go ahead and work this one, see what we end up with. So we know it's going down. And we have to figure out it's going down by how much. Well, we know 22%, but how many does it go down? How many dollars, if you will, if we were talking about dollars, how many dollars does it go down? Okay, if you're struggling, one thing, the equation you could do is, you know you have 70 is your original, and then you're decreasing it by 22%. So you could say 22% of 70 is what? Or 70, you know, maybe write it like this. 22% of 70 gives you what number? So that would be the equation you could use for that. So you go 0.22 times 70 if you're struggling on that one.
Will the test be after 2.8? Like the test
Usually, it is something like you'll see under the application and problems, and sometimes we do those, sometimes we don't. For that, so we still have 2.6, 2.7, and 2.8. Okay, so what do we get? 0.22 times 70. Anybody?
15.4.
Exactly?
Yeah.
Came out exact?
Yeah.
Okay. So then 15.4 was our change, and since it's a decrease, we're going up or down?
Down.
Down, and so this goes to a 54.6. There you go. Okay. Is it viable to use a calculator on your homework to expedite this process so that you can do these quickly? Absolutely. Great. There's nothing wrong with it. Again, we don't use on the test, but as we get into these ones where it's the grind, you feel free to use your calculator on those. It's not bad to have one in class, even though we're not pulling them out and doing a bunch of work as a group with it. Not bad to have one in class. Okay, use your remainder of the time. When is this due? Tomorrow. So make sure with these assignments that are like 2 days, don't procrastinate.